The topic is statistics. Look at this question. Is your answer yes? If so, that's the correct answer. For a set such as 2, 4, 6, 8, median would be the average of the two middle terms. See 5 in this case, which is odd. Let's start from the basics. The first topic is arithmetic mean, or simply average. Mean, or simply average, is the sum of all terms in a set divided by the number of terms in the set. That's the relationship. For example, this is a set. The sum of all terms is 402. The number of terms is 10, and therefore mean or average is 402 divided by 10 equals 40.2. Some important observations about averages. The mean may or may not be a term in the set. If all the terms in the set are increased or decreased by the same value, x, the mean also increases or decreases by the same value, x. If all the terms are multiplied or divided by the same value, x, the mean also gets multiplied or divided by the same value, x. Mean may be greater than or less than median or mode of the same set. So there is no relationship between mean, median, mode as to which has to be greater. Out of the three, any could be the highest, any could be the lowest. Median. Median is the middle value, separating the greater and lesser half of a set. To find the median, first arrange the terms in a set in increasing or decreasing order. If the number of terms in the set is odd, median is the middle term, n plus 1 divided by 2nth term. If the number of terms in a set is even, the median is the average of the two middle terms, n divided by 2nth term, and the n divided by 2 plus 1nth term. Let's take some examples. The first example. This is a set. Let's arrange the terms in increasing order. We get this set. Number of terms is 11, and therefore median is going to be the 6th term. So the median is 10. The next example. Arrange the terms in the increasing order. We get this set. Number of terms is even. Therefore, median is the average of 5th and 6th terms in the set. It is the average of 10 and 15. So the median turns out to be 12.5. Some important observations about median. The median may or may not be a term in the set. It depends on whether the number of terms is even or odd. If the number of terms is odd, the median is definitely going to be a part of the set. If all the terms in the set are increased or decreased by the same value, x, the median also increases or decreases by the same value, x. If all the terms in a set are multiplied or divided by the same value, x, the median also gets multiplied or divided by the same value, x. Median may be greater than or less than mean or mode for the same set. Next, mode. Mode is the most frequent observation, or score, or element in the set, an observation which has the highest probability of occurring. Example, look at this set. The mode is 10 because this is the only observation that occurs twice. All the other observations occur only once. In case there are multiple terms which occur the most number of times, then all of them become mode. So one set can have multiple modes as well. Standard deviation. Very, very important. Standard deviation is used for measurement of variability or diversity in a set. It shows deviation from an expected value, which is the arithmetic mean for the set. The higher the standard deviation, the higher is the variation among data values, which means that the scores are highly scattered. Calculating standard deviation. See, GMAT will never ask you to calculate standard deviation, but the questions based on it would require you to have a basic idea of how standard deviation is calculated. So let's take a basic example. Consider a set consisting of the following 8 values. These are the values. Now let's go about calculating the standard deviation. We go about plotting these values. See, the first column represents the 8 values as they are. The second column represents the arithmetic mean of these 8 values, which is 5. And then the difference between the respective value and the arithmetic mean. The sign doesn't matter. It's about the deviation. Whether it's less or more, it doesn't matter. That's why the mod sign. Therefore, 2 minus 5 equals 3. 4 minus 5 equals 1. Likewise, then the square of these values, these are the respective square of the values in the fourth column, then the last column represents the sum of these values. Standard deviation is the sum of these values represented in the last column divided by n, the number of terms, and now square root. Therefore, square root of 32 divided by 8, in this case. The standard deviation for this set is 2. Now some very important observations about standard deviation. What happens if all the terms in the set are increased by a value of x? Imagine what would happen. Suppose I add 10 to each value. 2 will become 12, 4 will become 14 likewise. But then the mean 5 will become 15, and between 12 and 15, the difference would still be 3. Again, between 14 and 15, the difference would still be 1 again, and therefore nothing will change in these columns. Therefore, the standard deviation would remain the same. Similarly, if I subtract the same number from each of these observations, nothing will change. The standard deviation would remain the same. Now what happens if I double all the numbers? If I multiply all the elements, let's say in this case by 2, so 2 becomes 4, 4 becomes 8, likewise. The mean, 5, in effect, will become 10. Now, see the difference between 2 and 5 is 3, but the difference between 4 and 10 would be 6. So, see, this difference would double up. The value of square would therefore be 4 times. The value of the sum here, therefore, will be 4 times. But when we take square root, it will again become square root of 4. That is 2 times. So that means if we double up everything here, then the standard deviation would also double up. Suppose I make everything 1/3. Then everything would become 1/3. In effect, standard deviation would become 1/3. So these are some very important observations. If all the terms in the set are increased by the same value, the standard deviation remains the same. If all the terms in the set are decreased by the same value, the standard deviation remains the same. If all the terms in the set are multiplied by the same value, the standard deviation also gets multiplied by the same value. If all the terms in a set are divided by the same value, the standard deviation also gets divided by the same value. Very important. Some other useful terms in statistics. Range, the difference between the greatest and the smallest observation in a set. For example, this is a set. The highest value is 200. The lowest value is -100. Therefore, the range is 200 minus -100 equals 300. Variation. Variation is the square of standard deviation. Now let's get on to learning by examples. Please solve this question. There are 3 parts to this question. So it says that the highest term is 3 standard deviations above the mean. So this gap is 3 sigma. Then the lowest term is 4 standard deviations below the mean. So this gap is 4 sigma. So the difference between the highest and the lowest term is 7 sigma, 7 standard deviations, which is equal to 140. The range, 7 sigma, equals 140. So the standard deviation is 20. That's the first answer. Now it says that the highest term is 200. If 200 is the highest term, 140 is the range. Lowest term becomes 200 minus 140 equals 60. And this gap is 3 sigma. Sigma is 20. So this has to be 200 minus 60 equals 140, or 60 plus 4 sigma equals 60 plus 80. It is 140 either way. So the lowest term is 60, and the mean is 140. These are the answers. Please look at this question. The best approach in these questions is to deal with the totals. So find the difference in the total amounts before and after the incident. So earlier, total weight of the class was 25 students, with average weight 100 pounds. So the total weight was 2,500 pounds. Later, when 5 students were added, now 30 students with average weight 110. So the new total turns out to be 3,300 pounds. The difference is 800 pounds. So the average weight of the 5 new students was 800 divided by 5 equals 160 pounds. That's the answer. Look at this question, please. Jack has scored 70% in 4 exams. That's 280. Now he knows he cannot score more than 60 in 2, so 60 times 2, that's 120. Not more than 70 in 1, so 70 times 1. We are taking the most optimistic case because the question says the minimum average score in the remaining 5 exams. So in all the other exams, we are taking the maximum possible scores. So 5 exams remain. This total is 470. For 80% marks in all 12 exams, the total has to be 12 times 80 equals 960. Out of 960, the most optimistic case is 470 in the 7 exams, so he needs to score 490 in the remaining 5 exams. He must score 98% in the remaining 5 exams to have any probability of scoring 80% overall. That's 98%. Poor Jack. Look at this question. There are 3 parts to this question. Please pause the video and try solving it. Originally, it is 40 times 50 equals 2,000 inches, the total height. Then 5 students joined. So total 45 students and average height increased by 1 inch to 51. This product is 45 times 51 equals 2,295. The difference is 295 because of the 5 new students. So the average height of the 5 new students is 295 divided by 5. That is 59. Second question. The shortest student is 55 inches tall. Out of these 5, the shortest student is 55 inches tall. Maximum possible height of the tallest guy, let's assume it to be x. The language says shortest of the new students. That means these 3 are definitely taller than the shortest student. We need to minimize these 3 values so that x is maximized. The sum we know is 295. We determined here the sum of heights of these 5 students is 295. We can't take 55 again because he is the shortest. It's given. It's unique, shortest of the 5 students. So others have to be taller. We can take the least possible values. Assume that all the other 3 are exactly 56 inches tall. So this is 223 plus x equals 295. Turns out that x is 72. So the maximum possible height of the tallest of the new students, in this case, is 72 inches. Look at this one now. It says that the tallest student is 80 inches tall. So this is 80. Maximum possible height of the shortest of the new students. So again, we assume it to be x. We want this to be maximum, so we will minimize the other 3. Other 3 become x plus 1 each, and that they all add up to 295 once again. So 4x plus 3 plus 80 would be equal to 295. Turns out 4x plus 83 equals 295. 4x equals 212, and therefore x is 53. So the maximum possible height of the shortest of the new students is 53 in this case. Look at this question. Please pause the video and try solving this. In 1990, the average age was 50. In 1991, each nurse will grow older by 1 year, and therefore the average age would increase by 1. The average age would be 51 in 1991. In 1994, something happened. 20 nurses retired at 60. So in 1994, the average age would be 54. You see, in 1990, it was 50. So in 1994, average age of all 100 nurses would be 54. The sum of their ages would be 54 times 100. Then 20 nurses retired at 60. So the sum of the ages of the active 80 nurses would be 5,400 minus 1,200. That is 4,200. Dividing this by 80 would make it 52.5. So 52.5 is the average age in 1994. In 1996, the average age of these 80 nurses would be 54.5. Come to 2000, something happened here. Now 2000. First of all, the average age of these 80 remaining nurses would become 58.5. Effect on total, 6 more times 80, and now 40 more nurses joined at the age of 25. So the total turns out to be 4,680 plus 1,000 equals 5,680. That's the total. And now there are 120 nurses, 80 plus 40. So we need to solve this. Turns out to be 568 divided by 12 equals 47.33. So the answer here is 47.33 here. One more example. Look at this. 4xy and 2yx. The average is 33. When a digit is of the form xy, it can be written as 10x plus y, and therefore 4xy has to be 40x plus 4y. Similarly, 2yx would be 20y plus 2x. Now their average is 33, so their sum must be 66. Add them up, we get 42x plus 24y. Either you divide this by 2 and equate this to 33, or you directly equate it to 66. It is the same thing. Now 42x plus 24y equals 66, and of course x and y are integers. This is possible only when x equals y equals 1. What is the average of x and y? The answer is 1. Look at the next question. 30 students decided to buy an article, so total cost 30K. Then 5 backed out. 25 remain, and the per head cost increased by 16. So now this is 25K plus 16, and they both are equal because the price of the article would be the same. On solving, we get 5K equals 400. K equals 80. Price of the article is 30K. So this is $2,400. That's the answer. Some DS practice questions now. Please look at this one. Pause the video. Is the mean of the set one of the integers in the set? That's the question. Now statement 1. The common difference is the same. So something like 1, 3, 5. The difference between any two consecutive terms is the same. So if there are odd number of terms, there would be a middle term that would become the mean. But if the number of terms is even, for example in this case, the mean would be the average of the two middle terms. The mean would be 4. So yes is possible in this case, and no is possible in this case. Therefore, statement 1 is not sufficient. Statement 2 alone is of course not sufficient. This is too little information. On combining the cases in which I was getting no as an answer, the cases where the number of terms was even, these cases get eliminated. Whenever the number of terms would be odd and the common difference would be same, the middle term would be the mean. So in this case, see 3 is the mean. You can't add one more term. The number of terms becomes even. You have to add 2 more, and now this term would be the mean. So combining worked. We got yes as an answer. Therefore, the right answer here is option C. Look at this one now. Similar question. Please pause the video, solve it yourself. The difference between any two consecutive terms is the same. So similar to last question. If it is something like 1, 2, 3, we get yes as an answer. If it is 1, 2, 3, 4, we get no as an answer. So statement 1 is not sufficient. Look at statement 2. The range is even. This alone is, of course, not sufficient. This doesn't convey much. On combining, range doesn't convey much because if the common difference is something even, for example 1, 3, 5, the range is even. Range is 4. We are getting yes as an answer. And if it is 1, 3, 5, 7, see still the range is even. But because the number of terms is also even, we are getting no as an answer. The mean for this set would be 4, which is not a part of the set. Combining doesn't help because knowing that range is even doesn't help much. Therefore, the right answer is option E. Let's look at the next question now. A similar question. Please pause the video, solve it yourself. Statement 1. The difference between any two consecutive terms in x is the same odd integer. Now, we know that the difference is something odd. For example, this. In this case, the answer is yes. In this case, the answer is no. Yes and no, both are possible. So statement 1 is not sufficient. Statement 2 is, of course, not sufficient. It carries little information. On combining, we know that the range is even. So if the range is even and the common difference is odd, the number of terms would be odd. See, the common difference is odd. So for the range to be even, the number of intervals has to be even. Remember, the number of terms is always one more than the number of intervals. For example, this one. See, there are 2 intervals, 1, 2, and there are 3 terms. In this case, there are 4 terms, so there are 3 intervals. Right. So if it is given that the common difference is odd, and for the range to be even, the number of intervals would be even, and therefore the number of terms would be odd. So cases where number of terms is even would need to be eliminated. And whenever the number of terms is odd, and it is an arithmetic progression, meaning the difference between any two consecutive terms is the same, then the middle term happens to be the mean as well as median for that set. So combining, we are able to get to a consistent yes as an answer. Combining works, and therefore the right answer is option C. One more question. Look at this. What is the standard deviation of a set of integers x? When each term is trebled, the standard deviation becomes 30. That means originally the standard deviation must have been 1/3 of 30. It must have been 10. Statement 1 is sufficient. When each term is halved, the standard deviation becomes 5. That means originally the standard deviation must have been double of 5. Originally it must have been 10. Statement 2 is also sufficient. The right answer is option D. Look at this one. When each term is increased by the same value k, the standard deviation for x becomes 30. We know adding any same value to each term would not have any effect on the standard deviation. So if the standard deviation is 30 now, it must have been 30 earlier as well. So statement 1 is sufficient. Look at statement 2. Each term is multiplied by k, the standard deviation becomes 10. If the standard deviation was originally, say, sigma, when each term is multiplied by k, the standard deviation also gets multiplied by k, and this value is equal to 10. There are two unknowns, one equation. This cannot be solved. So 1 is sufficient, 2 is not, and therefore A is the correct answer choice.